October 24th, 1944. The Sibuyan Sea, Philippines. Lieutenant Commander Ellis from the USS Intrepid rolled his Curtiss SB2C Helldiver into a 70-degree dive, the big right R2600 Cyclone engine howling as airspeed built toward 240 knots. Below him, the Japanese battleship Musashi, 863 feet of armored steel, twisted desperately in the crystalline water. Ellis pushed the dive steeper. 6,500 feet, 5,000. The world narrowed to the illuminated reticle in his gun sight and that massive ship filling his vision. His body pressed harder into his seat as gravity multiplied. 3G. 4G. The edges of his vision began to grey. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. At 3,000 feet, his hand found the bomb release. The 1,000-pound bomb dropped cleanly from the internal bay. Then came the pullout. Ellis hauled back on the stick. 5G, 6G, 7G. His vision tunneled to a pinpoint. Blood drained from his brain toward his legs. Blackness crept in from the periphery. But his hand stayed firm on the stick, pulling. The Helldiver's reinforced airframe groaned but held. At 1,500 feet, still pulling maximum G-force, still conscious through sheer discipline and training, Ellis leveled out. Behind him, his radioman gunner watched the bomb strike home, a blooming flower of fire and shrapnel on Musashi's forward deck. What Japanese observers aboard that doomed battleship witnessed that day challenged everything they understood about American dive bombers. These new aircraft didn't just dive steep and pull out. They held dives longer, pulled harder, and still delivered their bombs with devastating accuracy. One Japanese officer, watching from Musashi's bridge, would later report that the American dive bombers seemed to fall like stones only, to recover at impossibly low altitudes while still maintaining bomb-run precision. The psychological impact of witnessing aircraft pull 7G dives while maintaining attack accuracy was profound. For Japanese naval forces that had spent 3 years mastering their own dive-bombing techniques, watching American pilots routinely execute maneuvers that should have caused unconsciousness represented something more unsettling than mere technical superiority. It suggested a fundamental shift in the Pacific Air War that Japanese military doctrine had no answer for. The path to this moment began not with triumph, but with frustration and controversy. In May of 1939, the United States Navy issued specifications for a new dive bomber to replace the Douglas SBD Dauntless. The Curtiss Wright Corporation, leveraging its decades of aviation experience, submitted a design that looked revolutionary on paper. The SB2C would carry a 1,000-pound bomb internally, possess greater speed and range than the Dauntless, and fit 2 aircraft onto the 40 by 48-foot carrier elevators planned for the new Essex-class carriers. Raymond C. Blaylock's design team faced competing demands. They needed greater performance, heavier armament, internal bomb storage, folding wings, and all of this in a compact footprint dictated by carrier elevator dimensions. The solution was a short-coupled design, one where the distance from wings to tail was unusually abbreviated. This configuration inherently created stability problems. Blaylock compensated with distinctive large tail control surfaces that would become the Helldiver's visual signature. The prototype XSB2C-1 first flew on December 18, 1940. Almost immediately, problems emerged. The aircraft exhibited poor low-speed stability. High-speed handling proved touchy. The Wright R2600 Cyclone engine, itself still under development, suffered reliability issues. On February 9, 1941, an engine failure during landing approach nearly killed the test pilot. Wind tunnel tests had predicted unacceptable stall speeds and poor handling characteristics, but the urgency of impending war pushed the Navy to order 370 aircraft in November of 1940, despite these known deficiencies. Development continued through 1941 and into early 1942 as war raged across the Pacific. The first production SB2C-1 rolled out in June of 1942, It was a disaster. Electrical systems failed repeatedly. The aircraft was dangerously underpowered, with its original 1,500 horsepower engine. In January of 1943, a production aircraft suffered catastrophic wing failure during a dive test. The entire tail had separated. Curtiss-Wright found itself under investigation by the Truman Committee examining wartime production failures. The company had to establish a separate post-production line just to repair the defective SB2C second before they could be delivered to operational squadrons. Pilots who test flew the early models hated it. The aircraft earned nicknames that reflected this contempt: the Beast for its growling engine noise and demanding nature, Big-tailed Beast for its oversized tail surfaces. Most damning was Son of a Bitch, Second Class, a profane play on the official SB2C designation. Captain Jocko Clark, commanding the 2nd USS Yorktown, was so disgusted with the SB2C that he insisted on keeping his SBD Dauntlesses for his July 1943 deployment. Maintenance crews despised the aircraft for its frequent electrical failures and complex systems. Pilots found it heavy on the controls and unforgiving of mistakes. The Navy seriously considered cancelling the entire program. What saved the Helldiver was the SB2C3 variant, which began production in the spring of 1944. Engineers made critical improvements that transformed the troubled aircraft into a capable weapon. The most important change was the new Wright R260020 engine producing 1,900 horsepower, a substantial 400 horsepower increase. This extra power fundamentally altered the aircraft's handling characteristics, making it responsive rather than sluggish. The improved engine permitted installation of a 4-bladed Curtiss electric propeller instead of the original 3-bladed design, increasing efficiency and climb performance. The perforated dive brakes represented the second crucial modification. During testing, engineers discovered that the SB2C experienced severe tail buffeting and loss of lift at high dive speeds due to compressibility effects. The aircraft was approaching speeds where airflow over the tail surfaces became supersonic, creating dangerous control problems. The solution was elegant. By drilling numerous small holes in the dive brakes, engineers improved airflow and dramatically reduced buffeting. This allowed pilots to hold steeper dives longer without losing control. The SB2C3 could sustain a 78-degree dive angle, nearly vertical, while maintaining controllability. 4 rocket rails under each wing expanded the aircraft's offensive capabilities beyond bombs. The aircraft could now carry 8 5-inch high-velocity aircraft rockets, providing devastating firepower against both ships and ground targets. These improvements arrived just in time for the major carrier offensives of late 1944. By the time of the Philippine Sea battle in June and Leyte Gulf in October, the SB2C3 equipped the majority of Navy dive bomber squadrons. The aircraft that had been maligned just months earlier was about to validate its design in the largest naval battle in history. The specifications of the SB2C3 revealed an aircraft that was larger and more capable than its predecessor in every category. Wingspan measured 49 feet 9 inches, folding hydraulically to approximately 20 feet for carrier. Storage. Total length was 36 feet 9 inches. Empty weight was 10,550 pounds, climbing to 16,616 pounds, fully loaded for combat with bombs, fuel, and ammunition. That Wright R260020 engine spinning its 4-bladed propeller pushed the Helldiver to a maximum speed of 294 miles per hour at 12,400 feet. Cruising speed was 158 miles per hour, remarkably close to the F-6F Hellcat fighter's cruising speed. This meant strike packages of fighters, dive bombers, and torpedo bombers could fly together without the dive bombers slowing the formation. Combat range extended to 1,200 miles with drop tanks, giving task force commanders flexibility in strike planning. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Service ceiling reached 25,000 feet, high enough to start attack dives from altitudes beyond most anti-aircraft fire. The offensive armament reflected lessons learned from 3 years of Pacific combat. Two 20mm cannon, one mounted in each wing, provided heavy forward-firing punch. Each cannon carried ammunition at a rate of 1,200 to 1,500 rounds per minute. This was devastating firepower that could tear apart lightly built Japanese aircraft or strafe ground targets. The internal bomb bay, one of the original design requirements, carried that 1,000-pound bomb. Alternatively, the aircraft could carry various combinations of smaller bombs depending on the mission. The SB2C could also carry a Mark 13 torpedo externally for anti-shipping strikes, though this configuration was rarely used as torpedo attacks were TBM Avenger missions. Defensive armament consisted of twin 30-caliber machine guns in a rear-facing flexible mount operated by the radioman gunner. The turtleback design feature allowed this gunner position to retract for better aerodynamics during flight and extend for combat, giving the gunner a significantly improved field of fire compared to earlier dive bombers. Armor protection for both pilot and gunner had been substantially improved based on combat experience. Self-sealing fuel tanks added 212 pounds of protective rubber coating, preventing the catastrophic fires that had killed so many pilots in earlier unprotected aircraft. The pilot sat behind armor plating that would stop rifle-caliber bullets and most shrapnel. The structural design incorporated heavy-gauge aluminum with redundant load paths. This meant battle damage that would down a lighter aircraft might leave a Helldiver still flyable. The airframe was designed to withstand combat loads up to 9G positive and 4G negative, though operational doctrine called for limiting pullouts to 5 or 6G to prevent pilot blackout. The dive bombing procedure the Navy developed for the SB2C was precise and demanding. Strike packages would approach targets at 14,000 feet, beyond the effective range of most Japanese anti-aircraft guns. Fighter escorts would sweep ahead, engaging any defending aircraft and suppressing anti-aircraft positions with strafing runs. At approximately 10 miles from target, the dive bomber formation would begin climbing to their roll-in altitude. Pilots would reach 15,000 to 18,000 feet, depending on target defenses and tactical situation. The higher the roll-in altitude, the longer the dive, which increased accuracy but also increased exposure to anti-aircraft fire. The lead aircraft would waggle wings, signaling the start of the attack. One by one, bombers would roll inverted, pull through into a dive, and plummet toward their targets. The prescribed dive angle was 70 degrees, nearly vertical. This steep angle simplified bombing calculations dramatically. When diving that steeply, the bomb's trajectory became nearly straight down. The pilot simply had to point the aircraft at the target, compensate for wind at the target's motion, and hold the dive until bomb release altitude. The physical demands on the pilot during this phase were substantial but manageable. Dive speed built toward 240 knots, roughly 276 miles per hour. The perforated dive brakes, extended by the pilot, controlled this speed and prevented dangerous compressibility effects. Air rushing through the holes created a distinctive sound, part howl, part scream. Japanese sailors reported that the sound of approaching Helldivers was distinctive and terrifying. At approximately 3,000 feet, the pilot would check his Mark 8 reflector gun sight. This device projected an illuminated reticle onto an angled glass plate, allowing the pilot to aim without losing visual contact with the target. The pilot compensated for the target's movement, wind drift, and altitude in that brief moment. At 3,000 to 2,500 feet, the pilot pressed the bomb release. The internal bomb bay doors opened, the 1,000-pound bomb dropped free, and the bay doors closed. The entire process took less than a second. Immediately, the pilot began the pullout. This was the moment of maximum stress, both for aircraft and pilot. The pilot hauled back on the stick, pulling the Helldiver's nose up from its 70-degree dive toward level flight. This maneuver generated tremendous G-forces. At typical dive speeds and pull-out rates, pilots experienced 5 to 7 G, meaning they weighed 5 to 7 times their normal weight. Blood drained from the brain toward the lower body. Vision grayed at the edges, then tunneled to a narrow point. At 7G, most pilots would experience complete loss of vision while remaining conscious, a condition called grey out. Some pilots would lose consciousness entirely, blacking out for several seconds. The Helldiver's structure had to withstand these same forces. 7G on a 16,000-pound aircraft generated 112,000 pounds of force on the wings and fuselage. The reinforced spars, heavy-gauge aluminum skin, and robust construction that made the aircraft heavy and unpopular with early pilots now proved essential. By 1,500 feet, still pulling maximum G, the pilot would reach level flight. The nose came up, speed bled off, and the pilot would roll wings level while simultaneously advancing throttle. At this point, the Helldiver was barely 500 feet above the water, traveling at high speed, directly over or very near the enemy fleet. Every anti-aircraft gun that could depress low enough would be firing at the escaping dive bomber. Masts, smokestacks, and superstructures flashed past as the pilot jinked and maneuvered, trading altitude for speed, trying to escape the killing zone. The radio man gunner, recovering from the same G-forces that affected the pilot, would extend his twin, 30-caliber machine guns and begin defensive fire against any pursuing enemy fighters or nearby gun positions. The entire attack, from roll-in to escape, took approximately 40 to 60 seconds. In that minute, the pilot had to maintain precise control through a 70-degree dive, achieve proper dive speed, track a moving target, release at the correct altitude, survive a 7G pullout that threatened unconsciousness, and escape at wave-top height through concentrated anti-aircraft fire, then do it again on the next mission. The training program that produced pilots capable of this feat was extensive and demanding. Prospective naval aviators underwent initial flight training lasting approximately 1 year, accumulating 250 to 300 flight hours. Those selected for dive bombing received additional specialized training at operational training squadrons. This training began with basic dive bombing techniques at shallow angles against stationary targets. Gradually, instructors increased dive angles, decreased release altitudes, and introduced moving targets. Pilots learned to judge aircraft attitude by instrument and by sight. They practiced dive entries until rolling inverted, and pulling through became instinctive. They drilled emergency procedures until they could recover from unusual attitudes without conscious thought. Most importantly, they learned to function while experiencing G-forces that threatened consciousness. Repeated exposure to high G pullouts built tolerance. Pilots learned techniques to maintain blood flow to the brain. They would grunt forcefully, tensing abdominal muscles to prevent blood pooling in the lower body. They would hook their feet under the rudder pedals and press, using leg muscle tension to maintain blood pressure. These techniques, combined with training and experience, allowed pilots to remain conscious and functional while pulling 6 or 7G. By the time a pilot reached an operational squadron aboard a fleet carrier, he had completed hundreds of practice dives and accumulated 300 to 400 flight hours. He understood his aircraft's capabilities and limitations intimately. He had internalized the dive bombing procedure until he could execute it under stress, at night, in bad weather, or while under fire. The proof of this training program's effectiveness would be demonstrated in combat over the Philippine Sea and at Leyte Gulf. American dive bomber pilots would consistently achieve hit rates that astounded both their own intelligence analysts and Japanese observers. The doctrine and tactics developed for the SB2C built on 3 years of Pacific combat experience. The Navy had learned, often through costly trial and error, what worked in carrier aviation and what didn't. Strike packages were carefully coordinated affairs. A typical attack on an enemy fleet would launch from multiple carriers simultaneously. Fighter escort would consist of F-6F Hellcats, usually twice as many fighters as bombers. Some fighters would fly high cover, positioned to intercept enemy fighters attempting to attack the strike package. Other fighters would fly close escort, remaining with the bombers throughout the attack. The fighter bombers would strafe anti-aircraft positions immediately before the dive bombers began their runs, suppressing defensive fire at the critical moment. TBM Avenger torpedo bombers would coordinate their attacks with the dive bombers. Ideally, dive bombers would attack from one direction, while torpedo planes attacked from another, splitting the enemy's defensive fire. This hammer and anvil tactic had proven devastating at the Battle of the Philippine Sea in June of 1944. Navigation to and from targets relied on radio direction finding, radar, and dead reckoning navigation. Strike leaders carried sophisticated equipment that allowed them to home on the carrier's radio beacon for return flights. This was essential, as strikes often launched at maximum range and aircraft damaged over target or low on fuel needed guidance to find their carriers. The air group, commander or strike leader, controlled the entire attack through voice radio. He would assign specific targets to different squadrons, coordinate the timing of attacks, and order sequential strikes if the first wave didn't achieve desired results. This required a leader with combat experience, sound judgment, and the ability to make critical decisions under fire. Formation, flying discipline was critical. Bombers approached targets in formations that allowed each pilot clear visual contact with his wingman and leader. The standard division was 4 aircraft, with 2 divisions forming a section of 8 aircraft. During the dive, pilots would space themselves to prevent mid-air collisions. The lead aircraft would roll in first, followed by the second aircraft a few seconds later, then the third and fourth. This created a continuous stream of dive bombers plunging toward the target, each separated by enough time and distance to be safe, but close enough that the entire attack occurred within seconds, overwhelming the target's defensive capabilities. Recovery aboard carrier after strikes required precise procedure. The carrier would steam into the wind to provide relative wind over the deck for landing. Pilots would enter the landing pattern, or brake, at specific altitudes and positions. The landing signal officer on the carrier's deck would use colored paddles to guide each pilot to proper approach speed, altitude, and glide slope. The SB2C's landing characteristics were challenging. The aircraft's short-coupled design made it sensitive to control inputs during the critical landing phase. The tailhook had to catch one of several arresting wires stretched across the deck. If the pilot came in too high, he would miss all wires and have to attempt another landing. Too low, and he would strike the carrier's stern, likely destroying the aircraft and killing the crew. The margin for error was measured in feet and seconds. Experienced SB2C pilots developed techniques that made carrier landings routine, but the aircraft never forgave carelessness or inattention. More than one pilot discovered that the Helldiver demanded respect during every phase of flight, from launch to landing. By October of 1944, these techniques, tactics, and training had been refined into a systematic capability. The U.S. Navy possessed the best carrier-based dive-bombing force in the world, flying an aircraft that, despite its troubled development, had evolved into a capable weapons platform. Japanese naval aviation understood the threat. Intelligence reports throughout 1944 warned of new American dive bombers with improved performance. Captured American aircrew were interrogated specifically about their aircraft's capabilities. Japanese pilots who survived encounters with SB2Cs reported that the new bombers were faster, more heavily armed, and more durable than the Dauntlesses they had faced earlier in the war. But Japanese military leadership faced an impossible situation by October of 1944. The combined fleet had suffered catastrophic losses at Philippine Sea in June. Experienced pilots had been killed or wounded at rates far exceeding replacement capacity. Training programs had collapsed under pressure of shortened timelines and fuel shortages. Industrial production struggled under Allied bombing and blockade. New aircraft designs like the Kawanishi N-1K Shiden fighter showed promise, but entered production too late and in insufficient numbers. The decision to defend the Philippines came not from confidence, but desperation. If the Americans secured the Philippines, they would cut Japan's shipping lanes to resource-rich territories in Southeast Asia. Oil, rubber, tin, and other critical materials would be interdicted. Japan's ability to continue the war would collapse within months. Vice Admiral Takeo Kurita's center force, built around the super-battleships Yamato and Musashi, represented one of the combined fleet's last operational strike forces. The plan was audacious. Kurita's battleships and cruisers would transit the Sibuyan Sea, penetrate San Bernardino Strait, and attack the American invasion fleet off Leyte Gulf. While American carriers and battleships were drawn north by a decoy force, Kurita's big guns would devastate the vulnerable transports and landing craft. It was a gamble with the entire Japanese Navy at stake. October 24th dawned clear over the Sibuyan Sea. At 8:20 a.m., an SB2C Helldiver from the USS Intrepid, on radar picket duty, detected Kurita's force on its radar at a range of 55 miles. The radar operator noted the return was massive, indicating a large formation of ships. Lieutenant Commander Ellis, leading Bombing Squadron VB-18, received the contact report while circling high above the Philippine waters. Within minutes, strike coordinators aboard multiple carriers were planning attacks. This was the moment American carrier aviation had trained for. A major Japanese surface force, caught in daylight, beyond range of friendly air cover, steaming through restricted waters that limited evasive maneuvering. Perfect conditions for dive bombing attacks. The first wave launched at 9:30 a.m. From the Intrepid and Cabot, 12 SB2C Helldivers and a handful of TBM Avengers, escorted by F-6F Hellcats, climbed to attack altitude and headed west toward the Japanese fleet. Kurita's force consisted of 5 battleships, including the giants Yamato and Musashi, 9 cruisers, and 13 destroyers. Together, they mounted hundreds of anti-aircraft guns ranging from 25mm automatic weapons to 127mm high-angle guns. The battleships could even fire their main batteries as improvised anti-aircraft weapons, creating massive shockwaves and airbursts intended to break up attacking formations. But Kurita faced a fundamental problem. His force possessed no fighter cover. The Japanese carriers that might have provided air defense had been stripped of their aircraft during the Philippine Sea battle. Land-based Japanese air units in the Philippines were already heavily engaged and couldn't provide sustained coverage. Kurita's ships would defend themselves or die. At 10:25, Ellis led his squadron over the Japanese fleet at 14,000 feet. The scene below was both beautiful and terrible. The emerald waters of the Sibuyan Sea glittered in the morning sun. Distant tropical islands rose green and lush from the sea. And cutting through these idyllic waters, the largest concentration of Japanese naval power left in the war. Ellis identified Yamato and Musashi immediately. The 2 super-battleships, displacing more than 70,000 tons each and mounting 18-inch main guns, were unmistakable. He decided both TBM Avengers and SB2C Helldivers would concentrate on these behemoths. The anti-aircraft fire began as coloured bursts, red, white, yellow, green, filling the sky ahead. Japanese gunners used different coloured tracers to help coordinate fire. The pattern was beautiful and deadly. Ellis waggled his wings and rolled inverted. The world flipped. Sky became sea. Sea became sky. He pulled through into the dive. Below, Musashi grew larger with each passing second. The battleship's captain ordered full evasive maneuvers. Musashi turned hard to port, creating a massive wake as 80,000 tons of steel and armor changed direction. Ellis compensated, adjusting his dive to track the ship's movement. Around him, other Helldivers plunged downward in sequence, the air filled with diving aircraft and anti-aircraft bursts. At 3,000 feet, Ellis released. The bomb fell free, and he immediately hauled back on the stick. 7G pressed him into his seat. Grey fog closed in from the periphery of his vision. He grunted forcefully, tensing his abdominal muscles. His legs pushed against the rudder pedals. Blood flowed to his brain, maintained consciousness. At 1,500 feet, still pulling hard, he levelled out. Behind him, Musashi disappeared in a column of water and smoke. The bomb had struck near the forward deck, not a direct hit but close enough. Damage from near misses would accumulate throughout the day. The torpedo planes from his strike achieved one confirmed hit on Musashi's port side and damaged the heavy cruiser Myoko badly enough to force her withdrawal. But the psychological impact of the dive bombing runs exceeded the physical damage. Japanese sailors watching from other ships observed American pilots holding dives to what seemed like suicidally low altitudes before pulling out. The precision of these attacks, delivered while the pilots must have been experiencing extreme G-forces, suggested a level of training and capability that exceeded Japanese expectations. The second wave arrived 2 hours later from the Essex, Lexington, and Intrepid. VB-15 from the Essex, flying SB2C 3 seconds, scored 10 bomb hits on Musashi during this attack. Lieutenant Commander James D. Ramage led this strike, coordinating his dive bombers with TBM torpedo planes from VT-15. The combined attack overwhelmed Musashi's defenses. Dive bombers struck from one direction, while torpedo planes attacked from another, exactly as doctrine prescribed. Japanese anti-aircraft gunners had to choose which threat to engage, and in that moment of divided attention, American aircraft penetrated the defensive fire. Musashi's gunners fired everything they had. The 25mm automatic weapons created a curtain of tracers at close range. The 127mm high-angle guns threw up barrage fire, creating walls of airbursts. The main 18-inch guns fired special anti-aircraft shells designed to create massive concussive blasts. When those guns fired, Musashi literally disappeared in clouds of smoke lit from within by flame. The shockwave was powerful enough to affect nearby ships. One American pilot reported that watching those main batteries fire was more frightening than dangerous, but the psychological effect was profound. Despite this wall of fire, the SB2Cs pressed their attacks. Pilots held their dives through the anti-aircraft fire, released at prescribed altitudes, and pulled out successfully despite the extreme G-forces. Of the 12 Helldivers in VB-15 strike, 11 returned safely to their carriers. The one loss was attributed to operational problems, not enemy action. A third wave from the Enterprise and Franklin attacked Musashi in the afternoon. By this point, the great battleship had already absorbed punishment that would have sunk any other vessel afloat. Witnesses reported she was listing to port, her forward deck awash, trailing oil and smoke, but she continued fighting. Her anti-aircraft guns continued firing. Her damage control teams fought floods and fires with desperate determination. The Franklin's Air Group, led by Commander James M. Minnie, delivered what would be Musashi's death blow. SB2C Helldivers from VB-13, attacking through intense anti-aircraft fire, scored multiple hits. TBM Avengers added several more torpedo hits to the toll. One dive bomber pilot, pulling out from his attack run at barely 500 feet, passed so close to Musashi's superstructure that he could see individual Japanese sailors manning their guns. The precision required to deliver attacks at such close range, while experiencing 7G pullouts, represented the pinnacle of dive bombing technique. At 1500 hours, a fourth strike arrived, led again by the Intrepid and joined by aircraft from the Cabot. This attack blended with a strike from the Franklin in what became the final coordinated assault on the doomed battleship. 12 more Helldivers from VB-18, led again by Ellis on his second sortie of the day, dove on Musashi. Ellis remembered later that by this fourth attack, Musashi was clearly dying. She was low in the water, listing heavily, and her anti-aircraft fire had diminished noticeably. But the battleship's crew never surrendered. They continued firing, continued fighting, continued trying to save their ship until the very end. 4 more bombs struck Musashi during this final attack. Multiple torpedo hits, the exact number disputed but at least 11 confirmed, completed her destruction. At approximately 1900 to 35 hours, having absorbed at least 17 bombs and 19 torpedoes over the course of 7 attacks, Musashi finally capsized and sank. Of her crew of 2,199, more than 1,000 perished. The Battle of the Sibuyan Sea demonstrated the devastating effectiveness of coordinated carrier strikes, employing improved aircraft and refined tactics. 5 fleet carriers and 1 light carrier from 3rd Fleet flew 259 sorties against Curtiss center force on October 24. The SB2C Helldivers carried the majority of these attacks, delivering the bombs that accumulated damage on multiple Japanese ships. Yet despite this weight of attack, American strikes did not neutralize Kurita's force completely. Only Musashi was sunk. The cruiser Myoko was damaged badly enough to withdraw, but Yamato, 3 other battleships, and 8 cruisers remained combat capable. Kurita reversed course temporarily, leading American observers to conclude erroneously that he had abandoned the operation. In fact, he was merely maneuvering out of range while his ships conducted damage control repairs, then resumed his advance after dark. The following day, October 25th, brought the battle off Cape Engano, where American carrier aircraft attacked the Japanese carrier decoy force. Here again, SB2C Helldivers demonstrated their capabilities. VB-20 from the Enterprise attacked the carrier Zuikaku, last survivor of the Pearl Harbor strike force, with 12 Helldivers led by Commander Riera. The attack began at 12,000 feet. One by one, the Helldivers rolled into their dives, plunging toward Zuikaku through multicolored anti-aircraft fire. The carrier maneuvered desperately, turning hard to avoid the falling bombs, but the precision of American dive bombing proved too accurate. Multiple bombs struck Zuikaku. The carrier absorbed tremendous punishment but continued to float. Additional strikes throughout the day added to the damage. By evening, Zuikaku was sinking, taking with her the last operational Japanese carrier crew that had seen Pearl Harbor. The attack on Zuikaku demonstrated another remarkable aspect of Helldiver operations. During the pull-out phase, when pilots were experiencing maximum G-forces and fighting to remain conscious, they were also at minimum altitude, passing directly over heavily armed warships. At this moment of maximum vulnerability, when the pilots were lowest, slowest, and most exposed, Japanese anti-aircraft gunners had difficulty depressing their weapons enough to engage the escaping aircraft. The SB2Cs were literally flying too low, too fast, and too close for many defensive weapons to track them. This tactical advantage was unintentional, a byproduct of the steep dive angles and low pull-out altitudes that improved bombing accuracy, but it proved significant in reducing American losses. Of the 262 SB2C Helldivers engaged during the 4-day battle, only 37 were lost, a remarkably low attrition rate of 14%. Many of these losses were attributed to operational causes, running out of fuel or ditching at sea, rather than enemy action. The human dimension of these attacks often gets lost in the statistics and tactical discussions. Each dive represented a moment when a pilot willingly placed himself at extreme physical and psychological stress, betting his life on his training, his aircraft, and his own ability to maintain consciousness through punishing G-forces. Consider the perspective of a 22-year-old ensign on his first combat mission. He has trained for this moment for more than a year, but no amount of training fully prepares you for rolling inverted at 14,000 feet, pulling through into a 70-degree dive, and watching a Japanese battleship grow larger in your gun sight while tracers and airbursts fill the sky around you. The noise is overwhelming, the engine roars, the wind screams through the dive brakes, the radio crackles with calls from other pilots. Anti-aircraft bursts create sharp cracks that you can hear even over the engine noise. Your heart pounds, your breathing becomes rapid and shallow despite your training. And then you pull the bomb release and immediately begin the pullout. 5G, 6G, 7G. Your body suddenly weighs over 1,000 pounds. Your vision begins to grey. You grunt, tense, squeeze your legs against the pedals. But the greyness continues to spread. Your vision tunnels to a pinpoint. You can barely see the instruments. Your peripheral vision is gone. And still, you hold. Back pressure on the stick. Pulling, pulling, pulling. At 1,500 feet, you level out. Vision slowly returns. Your body weight drops back to normal. You advance the throttle and dive for the deck, trading altitude for speed. Behind you, your bomb has either hit or missed. You may not even know which until the post-flight debrief. Ahead, you must navigate back to your carrier, land on a pitching deck, and do it all again tomorrow. Multiply this experience by dozens of pilots, across dozens of missions, over 4 days of continuous combat. The cumulative physical and psychological toll was substantial. Pilots lost weight from stress and G-force exposure. Some experienced temporary vision problems from repeated high-G maneuvers. Most had difficulty sleeping between missions, replaying attacks in their minds, but they continued flying because the mission demanded it, because their squadron mates depended on them, and because stopping was not an option. The Japanese perspective on poster, These attacks came from survivors who provided testimony after the war. Ensign Mitsuru Yoshi, serving in the rear generator room of the heavy cruiser Myoko, felt his ship shudder when a torpedo struck during the first wave attack on October 24. He recalled the thundering sound of Myoko's main guns firing at the attacking aircraft, and the immediate counter-flooding measures after the torpedo hit damaged the starboard-aft propulsion. Petty Officer 3rd Class Kazuhiro Hayakawa, stationed topside on the Musashi, witnessed the attacks firsthand. He described the incredible noise when Musashi's 18-inch main batteries fired anti-aircraft rounds. The shockwave so powerful it required ship-wide announcements ordering crew to move inside. He watched American dive bombers fall like stones, only to pull up at what seemed impossible altitudes. Able seaman Shigeji Tsuchiya, serving on the Yamato, had a battle station on the upper deck where he could observe the aerial combat directly. He remembered the continuous machine gun fire from Yamato's anti-aircraft positions and the sight of American aircraft diving through walls of fire to deliver their attacks. What struck these Japanese sailors most was the relentless nature of the attacks, wave after wave of American aircraft, each attack precisely coordinated, each pilot seemingly willing to press his attack to suicidal altitudes. The Japanese Navy had developed considerable respect for American dive bomber pilots after Midway, Coral Sea, and other battles. But the attacks at Leyte Gulf suggested evolution beyond mere competence. This was systematic application of superior training, superior equipment, and superior tactical doctrine executed by pilots at the peak of their capabilities. Japanese intelligence officers attempted to compile assessments of American dive bombing techniques from survivor reports. The reports consistently emphasized several points. American pilots held dives longer than Japanese, doctrine considered safe. American pilots maintained accuracy while experiencing G-forces that should have caused unconsciousness. American pilots coordinated their attacks with precision timing that overwhelmed defensive fire. Japanese defensive countermeasures proved largely ineffective. Evasive maneuvering by ships under attack merely delayed hits rather than preventing them. American pilots compensated for ship movements during their dives. Anti-aircraft fire, even when hitting attacking aircraft, often failed to prevent bomb release. Damaged American aircraft would complete their attacks before attempting to escape. The concentration of defensive fire, while sometimes downing American aircraft, could not prevent determined pilots from penetrating to bomb release altitude. One Japanese after-action report, captured and translated after the war, included the observation that American dive bombers appeared to be falling stones that somehow came alive at the last moment. This phrase, repeated in multiple reports, captured Japanese perception of the Helldivers' attack profile. The steep dive angle made the aircraft appear out of control or damaged. The late pullout, occurring at altitudes Japanese pilots would consider suicidal, seemed to violate physics. Yet consistently, American pilots recovered successfully and escaped. Japanese Navy leadership understood they faced a capability they could not match. Their own dive bomber force, built around the Yokosuka D-4Y Judy, possessed good aircraft and experienced pilots earlier in the war. But by October of 1944, the combination of pilot attrition, training program collapse, and fuel shortages had degraded Japanese dive bombing effectiveness to shadows of its former capability. The Japanese naval aviation training pipeline that once produced dive bomber pilots after 300 to 700 flight hours now graduated pilots with 100 hours or less. These barely trained aviators lacked the physical conditioning to tolerate high G-forces repeatedly. They lacked the experience to maintain situational awareness during steep dives through anti-aircraft fire. They lacked the skill to deliver accurate attacks while experiencing the physical stress of combat dive bombing. Some individual Japanese pilots still possessed exceptional skill, but individual excellence could not compensate for systematic institutional failure across the entire Japanese naval aviation arm. The implications extended beyond tactical defeats to strategic collapse. If Japan could not defend its surface forces against American carrier-based aviation, then every Japanese ship became vulnerable. If Japanese naval forces could not survive in waters where American carriers could operate, then the entire defensive perimeter contracted to only those areas beyond American carrier range. And American carriers, supported by the industrial might that produced Helldivers, Hellcats, and Avengers by the thousands, could reach anywhere in the Western Pacific. The broader impact of the Leyte Gulf engagements on Japanese naval strategy was profound. After October of 1944, the combined fleet ceased to function as an integrated fighting force. Individual ships and small task forces continued operations, but massed fleet actions became impossible. The risk of concentrated American carrier aviation made such operations suicidal. This drove Japan toward desperation tactics. If conventional attacks could not stop American forces, then unconventional approaches might. On October 25th, the same day American carriers were attacking the Japanese northern force off Cape Engano, the first organized kamikaze attacks struck American escort carriers off Samar. These suicide attacks, aircraft deliberately crashed into ships, represented acknowledgement that Japanese pilots could no longer compete with American forces through skill and training. Vice Admiral Takejiro Onishi, architect of the kamikaze strategy, understood the mathematics brutally. With approximately 100 serviceable aircraft facing potentially thousands of American planes, conventional tactics offered no hope of success. But if each Japanese aircraft could sink one American carrier by deliberately crashing into it, then favorable exchange rates became possible. The psychology behind this decision revealed how completely American carrier aviation had dominated the Pacific Air War. Japanese leadership concluded that their pilots, even when guided to targets, even when approaching through defensive fire, could not reliably hit American ships with bombs or torpedoes using conventional attacks. The accuracy and training required exceeded their diminished capabilities, but crashing an entire aircraft into a ship while requiring determination unto death demanded less precision than successful dive bombing. The aircraft became the weapon rather than the delivery system. This represented implicit admission of the superiority of American dive bombing technique and training. The kamikaze strategy would inflict significant damage on American forces over subsequent months, but it also represented strategic bankruptcy. Suicide attacks consumed aircraft and pilots irreplaceably. Each kamikaze mission was a pilot's final flight. There was no building of experience, no accumulation of veteran skills. Fresh pilots would fly one mission, then die. This was unsustainable, operationally, and catastrophic psychologically. By contrast, American dive bomber pilots flew dozens of missions, accumulated hundreds of flight hours, and returned to the United States to serve as instructors, passing their knowledge to new pilots. This created a virtuous cycle, where expertise multiplied across the entire force. The most experienced pilots became the best teachers, and the best students became the next generation of experts. The SB2C Helldiver, for all its developmental troubles and early reputation problems, became the weapon platform for this systematic excellence. By war's end, Helldivers had participated in every major carrier operation from late 1943 through August of 1945. They struck Japanese installations at Rabaul, attacked shipping throughout the Pacific, supported amphibious landings across dozens of islands, and participated in strikes against the Japanese home islands themselves. The aircraft's combat record vindicated the Navy's decision to persist through the early problems. SB2C Helldivers sank or damaged more Japanese shipping tonnage than any other American aircraft type during the war. They participated in sinking both Yamato and Musashi, the two largest battleships ever constructed. They supported the Marine Corps landings at Iwo Jima and Okinawa. They struck the Japanese fleet at anchorage in Kure Harbor. They proved that dive bombing, far from being obsolete, remained a precision strike capability that even advanced fighters could not fully replicate. The cost was substantial. Dive bombing remained one of the most dangerous missions in naval aviation. Combat losses, operational losses, and training accidents killed hundreds of pilots and aircrew throughout the war. The physical demands left many veterans with long-term health issues. Repeated exposure to high G-forces caused vision problems, back injuries, and cardiovascular stress. But the mission's importance justified the risk. Until the advent of precision-guided munitions decades later, dive bombing represented the most accurate method for destroying point targets from the air. A skilled dive bomber pilot could place a bomb within 50 feet of his aim point consistently. No other attack method approached this accuracy against moving ships or hardened targets. The doctrine developed around the Helldiver influenced post-war naval aviation significantly. The Navy retained dive bombing as a core capability through the Korean War, where Helldivers saw action during the Incheon landings and throughout the subsequent campaign. The aircraft remained in Navy and Marine Corps service until 1950, longer service life than most World War II combat aircraft. Foreign operators continued using Helldivers even longer. The French Navy operated SB2C Helldivers from the carrier Arromanches during the First Indochina War, conducting combat operations from 1951 through 1954. These aircraft proved that the basic dive bombing technique remained effective even in a post-World War II environment. The last Helldivers retired from military service with the Italian Air Force in 1959, 15 years after the first SB2C seconds entered combat at Philippine Sea. This longevity testified to the fundamental soundness of the aircraft's design once early problems were resolved. The legacy extends beyond the aircraft itself to the training methods, tactical doctrines, and institutional knowledge that American naval aviation developed around dive bombing. Modern carrier aviation no longer employs dedicated dive bombers. Fighter bombers and attack aircraft deliver precision-guided munitions from level flight or shallow dive angles. But the fundamental principles that Helldiver pilots mastered, coordinated strikes, precise timing, systematic training, aggressive tactics, and acceptance of risk to achieve mission objectives, remain core to naval aviation culture. The veterans who flew SB2Cs carried memories of these missions throughout their lives. Many could describe, decades later, specific details from specific attacks: the color of the water below, the shape of the target ship, the feel of the stick during pullout, the sound of anti-aircraft fire bursting around their aircraft. These experiences, intense beyond normal human activity, created bonds between pilots that lasted lifetimes. Squadron reunions brought together men who had shared moments when death seemed certain, when only skill and luck separated survival from oblivion. The unspoken understanding between combat veterans, those who truly know what it means to stake your life on training and equipment while diving toward an enemy who desperately wants to kill you, created connections that transcended normal friendship. The specific memory that haunted many pilots was the pull-out moment. That instant when you're pulling maximum G, vision graying, consciousness fading, and you must maintain stick pressure despite every instinct screaming to ease off. If you reduce back pressure too soon, you won't pull out. You'll fly into the water or the target at 240 knots. If you black out completely, you might recover too late to avoid terrain. So you fight, physically and mentally, to remain conscious and maintain pressure. You grunt, you strain, you squeeze, and somehow, impossibly, you remain conscious long enough to level out at 1,500 feet. Then you do it again tomorrow. This physical courage, combined with technical skill and tactical discipline, was what made American carrier dive bombing so devastatingly effective. Japanese observers recognized this even as they suffered under it. In testimony after the war, multiple Japanese officers specifically mentioned the determination of American dive bomber pilots. These men were not reckless or suicidal. They were highly trained professionals, executing extremely difficult maneuvers with precision, accepting calculated risks because the mission required it. The technical achievement represented by the SB2C's 7G dive capability deserves recognition. Engineering an airframe that could sustain such forces repeatedly while carrying weapons and maintaining flight characteristics required sophisticated analysis and robust construction. The perforated dive brakes alone represented inspired problem-solving. By drilling thousands of small holes in the dive brake surfaces, engineers eliminated compressibility buffeting that had plagued earlier designs. This allowed steeper dives and lower pull-out altitudes, directly improving bombing accuracy. The Wright R-2600 engine, after early reliability problems were solved, proved itself an outstanding power plant. Producing 1,900 horsepower from a radial design, It provided the thrust-to-weight ratio necessary for carrier operations while maintaining fuel efficiency for long-range missions. The engine's reliability improved dramatically as production matured, to the point where engine failures became rare events rather than common occurrences. The combination of structural strength, engine power, and aerodynamic efficiency created an aircraft that could execute its designed mission successfully, despite the extreme demands of carrier-based dive bombing. That this capability came from an aircraft initially condemned as a failure makes the achievement more remarkable. The institutional persistence that transformed the troubled SB2C-1 into the capable SB2C-3 demonstrated American military-industrial flexibility at its finest. Problems were identified, analyzed, and solved systematically. Each variant incorporated improvements based on combat experience and engineering analysis. The production line adapted continuously, implementing changes without halting aircraft delivery. This ability to recognize problems, commit to solutions, and execute improvements while maintaining production separated American industrial practice from adversaries who lacked such flexibility. Japanese and German aircraft designs often stagnated because limited production capacity made retooling expensive and time-consuming. American industry could simultaneously produce current variants, develop improved versions, and maintain older aircraft in service. The scale of Helldiver production illustrated this capability. Between 1942 and November of 1945, Curtiss and its subcontractors produced 7,140 SB2C Helldivers in multiple variants. This represented one of the largest dive bomber production runs in history. Peak production occurred in March of 1945, when factories delivered 605 aircraft in a single month, averaging over 20 Helldivers per day. At that rate, a carrier air group's entire dive bomber squadron could be equipped in less than 2 days of production. This industrial achievement underpinned the tactical and operational successes that aircraft like those of Ellis and his squadron mates achieved. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.